In the frog jumping across the road problem, not to be confused with the frog river jump problem, it is asking you to solve for the least or minimum amount of fixed jumps to get to a certain endpoint. You are given three integers, x, y, and d, jumping from position x to a position equal to or greater than y over a fixed jump distance, which is d. The desired result is not just solving a simple math problem, but solving it using the most efficient time complexity. They want you to be able to know how to navigate the code with the end result of providing the fastest runtime of a program, in this case providing an O1 response. Time complexity of O1, in its most simplest terms, means that there's always a fixed number of operations. When you start adding for loops, counters, and searching over ranges of numbers, the processing time begins to slow. There are a few ways to solve the frog jump lesson, and I'm going to go over the incomplete way, the slow way, and the best way. For the problem, we are given the numbers x, y, and d as 10, 85, and 30 respectively. For the first example I'm going to go over, correctness is 100%, but it failed the performance test because it timed out with larger numbers. Time complexity given was O, y, minus x. This is due to the number of jumps it must make when x and y become longer and further apart. Remember, in O1, there must be a fixed number of operations, or the operations must remain constant. It should become clearer as you see more examples shown here. Next example failed pretty much everything, even though it got the example test correct. It's returning the amount of loops it's taking to get to the endpoint of y. For this solution, the amount of loops was 3, and it was only showing it to be correct at 3 because the true answer really is 3. In this case, it just happened to be a lucky coincidence. But luck and coincidence only go so far. This is the first example of two correct solutions using O1 time complexity. As you will see in this solution and the second one, the distance is set or equal to the starting point, which is x, being subtracted from the endpoint, or y. The variable assigned as distance is fixed or constant, always equaling y minus x, or the endpoint subtracting from the start point. To put it another way, as stated at the beginning of the video, it's a fixed operation. In this solution, subtraction. This example uses an if and else statement to cover even-numbered distances and odd-numbered distances. Floor division is used to avoid floats or decimals and returns whole numbers. And because floor division rounds down, a 1 must be added on the odd-numbered results. This last solution wins our kiss of the day in keeping it simple. Even though you're using the math module, you still get 100% in performance because you're using the subtraction operation for distance. By using the ceiling function versus using floor division as shown in the previous example, it will automatically round up your results. And the bonus is, it will take care of the even and odd number occurrences, so there's no need to use an if and else statement. Pretty cool! Well, I hope you found this video helpful. Thanks for watching and happy coding!